All right, good people, here we go. We're going to find the derivative of these integral functions, of these area functions. I know that because the name of the function is f of x, capital F of x, and it equals this integral function, right? It's in terms of x because you tell me what x value to put. I put it up here and I find the area under the curve. But we're looking for f prime. Okay, well, let's find f prime. So we're going to take the derivative of this side, which really means take the derivative of this integral. But according to the second part of the fundamental theorem, if I'm taking the derivative of the integral, all I have to do is take the integrand, and wherever I see a variable in my integrand, I'm going to substitute the upper limit and then multiply by the derivative of what I just substituted. So really, my final answer would be cosine x squared. This is my derivative. The derivative of this integral defined by the integral of cosine t squared dt from 0 to x is cosine x squared. It's that simple. The derivative and the integral are going to cancel each other out. They're going to undo each other, and I'm just left with the function that we were trying to integrate to begin with. Okay, that's it. We're done. Part B. Can I find the derivative of capital F if I'm taking the derivative of this integral? Sure. All I'm supposed to do is take the function and substitute the upper limit, or rather the variable part, or the variable limit, substitute it into the variable, the dummy variable of the integral, and then multiply it times the derivative of what I plugged in. The derivative of 3x would be 3. And that's it. My answer is therefore 3e to the 6x. Not 3 to e, not 3e to the 6x plus c, because we're not taking an antiderivative. We're taking a derivative, so we're done. That's it. Is it really that easy? Yes, it really is. I'm going to show you the whole screen here. All right, so can I try the next one? F prime of x means that I'm taking the derivative of this function, natural log of the absolute value of 3t minus 1 dt. I'm supposed to take my function. Since I'm taking the derivative of the integral, they're going to undo each other. So I'm left with the natural log of the absolute value of 3 times something minus 1. But that something is whatever the variable limit is, which is x squared, the function of x. But don't forget, multiply by the derivative of the inside, which is 2x. So therefore, this equals 2x times the natural log of the absolute value of 3x squared minus 1. And we're done. Now be careful. When I get to letter D, I notice that my limits of integration are not set up the way they usually are with the constant on the bottom. So I'm going to have to flip them, which is fine as long as I introduce a negative. So I get this. And now I'm going to take the derivative. So we're going to take f prime, the derivative of f, which means I'm taking the derivative of this negative integral from 5 to 2x of the square root of 4t minus 1 dt. The derivative and the integral are going to undo each other. I'm still left with that negative, and I still have this function, which is the square root of 4 times something minus 1. What is that something? Well, it's the variable limit of integration. But then don't forget to multiply by the derivative of the inside, which is 2. My final answer would be negative 2 times the square root of 8x minus 1. And we're done. Taking the derivative is easy if I'm taking the derivative of an integral. Notice, this is not the antiderivative, right? We're not taking just the antiderivative of the inside function. We're taking the derivative of the integral, which is going to undo them, and then I'm left with the inside function. So it's a very, very Very, very thin line there. Let's do some from example 2, and then we'll jump to example 3. What am I looking for? Oh, look, I'm looking to take the derivative of the integral. They're going to undo each other. So I'm just left with the inside function, the integrand function, except wherever I see a t, I'm going to substitute the variable exponent, a variable limit, and then multiply by the derivative of the inside, which is 3x squared. So this is correct. Or you can clean it up a little bit and say it's 3x squared times tangent of 2x cubed. Done. Alrighty. I don't know which one to do next. Should I do B or C? I think C is pretty straightforward, right? Take the derivative of the integral. I'm left with this function, 2 times something minus 1. What goes into that something is the upper limit, or the limit with the variable, times the derivative of the inside, which is e to the x. And that's just going to leave us with e to the x times the square root of 2 e to the x minus 1. Some students say this is a shortcut. I agree with them. It is a shortcut. But it only works if I'm taking the derivative of an integral. If I'm just doing an integral, this is not what the shortcut says, right? I have to be taking the derivative of the integral for them to undo each other, and then I'm just left with that function on the inside. Let's do letter D here. I notice that the constant is not on the bottom, so I'm going to fix that. And then we're going to take the derivative of the integral. So that means I'm going to be left with the function. But be careful. E to the something squared. Well, what's that something? Sine 2x. Okay, so sine 2x times the derivative of this. Oh, but the derivative of this is a chain rule, where I take the derivative of the outside with the inside still in it times the derivative of the inside. So the final answer for this one would be something like 2e to the sine 2x squared, because there's a squared, right, times cosine 2x. Or here is a practice exam from 2009 for AB number 27. If f is the function given by this indefinite integral, then find f prime of 2. Well, be careful. I'm looking for the derivative at a specific value, but I have to find the derivative first. So I have to, if I'm looking for f prime of x, I have to take the derivative of this integral function first, and then I can plug it in. I can't plug it in right away and expect to be able to do it. So I'm going to take the derivative of the integral, which is the square root of something squared minus something. But what goes inside? Well, this 2x. So that'll be 2x minus 2x. Oh, but don't forget to multiply by the derivative of the inside, which would be 2. Or 2 times the square root of 4x squared minus 2x. And now, if I'm looking for f prime of 2, now I can plug 2 into that formula that we just found. And we can figure it out from there. Okay, so let's see. I took the formula that we got from f prime, and I'm just going to substitute 2 into that formula. This is going to be 2 times 2 is 4 times 4 is 16 minus 2 times 2 is 4. Well, that's going to be 2 square root of 12. And my answer is E. We're going to come back. We'll take a look at number 20 from 2013. Maybe you can take a look at this and see if you can get it going, and then we'll check it in the next video as we start. And then we'll put together what we know about area functions, integral functions, along with what we talked about with analyzing functions about increasing and concave up and all that business. We're going to put them all together. So let's come back on video 3 to do that.